Hello everyone. So today we are going to learn about isotopes. So learning intention would be to define an isotope and learn some examples of isotope. So by the end of the lesson, you should be able to understand the difference in subatomic particles of an isotope and name some examples of them as well. So okay, so just to think about isotopes, there are different Easter eggs, but what are common in them and what are different in them? How these eggs are different and how they are common. And the key vocabulary for today is isotopes and neutrons, the two important things. Okay, so in the last few lessons, we are learning about periodic table, atomic structure, and how we write on the periodic table, how the elements are written. So, in a periodic table, the elements are written like that. So, Na, for example, that is a symbol of the element, and that is for sodium. The symbol of sodium is Na. So, on the periodic table, you will find it like this, Na, and at the top, you will see a number. For this, it's 23. And at the bottom, you will see a number as well. That is 11 in this case. So the top one is your mass number. And the bottom one is your atomic number. So the mass number tells us how many electrons and neutrons in total present in the nucleus. So if you remember the structure of atom, in the middle of the atom, in the center, there is a nucleus. And that nucleus has the protons and neutrons in it. Okay, so the total number, if you add the total number of protons and electrons, that is known as the mass number, which is written at the top here, which is 23. Okay, so mass number or atomic mass, it's the same thing. It tells us how many protons and neutrons are in the nucleus. So the total number of protons and neutrons. Okay, so then the atomic number is written at the bottom, and it tells us how many protons are in the nucleus. So it tells you how many protons are there, and in a electrical neutral atom, the number of protons are always equal to the number of electrons. So in other words, if it has got 11 atomic number, so the number of electrons in it would be 11, and the number of protons in it would be 11 as well. So can you now found the number of protons, as I already said? So what would be the number of protons? You know the number of protons are same as the number of electrons and atomic number. So it's 11 here. So the number of protons would be 11. So what is the mass of the atom? So mass of the atom is the mass number, which is here at the top. That is 23. Then number of neutrons. Okay, so number of neutrons is a formula you can remember. So it is the mass number take away the atomic number. So you subtract the top number from the bottom number and you will get the number of neutrons. So 23 take away 11, it's 12 in this case. Okay, so there are 12 neutrons in sodium. So the mass number take away the atomic number. All right, so you need to remember this slide and you can refer back to it when you're doing questions. Okay, so can you just do with the previous slide example, can you calculate the number of protons and neutrons in the nucleus of the following atom? So I'll give you a little bit of example for the first one. So Mg, so that is an element, that's magnesium. And at the bottom, if you go to the previous slide, what is at the bottom? It is the atomic number. And at the top, 24, what is that? At the top, it's the mass number. All right, so now how many protons would be in Mg, magnesium? So you know the number of protons is equal to the number of electrons, which is equal to the atomic number. So if you go back, it tells us how many protons in it, atomic number. So if the atomic number is 11, it means the protons in here are, in this case, is 12, okay? Then how many neutrons? You know the formula from the last slide we have? For finding the number of neutrons, it's the mass number, take away the atomic number, okay? So it's 24, take away 12, which is 12 again. That's it. So you do the same thing for all the other elements, and can you just write next to here on your slide? You can type it, or you can write here number 1, 2, 3 like that, or you can do that in your books and click a photo and send it to me after this. Okay. I have attached this as a copy for everyone as an assignment for today's lesson. So you can type on the Google Doc and make sure you submit it when you are done so that I can see it, your work. Okay. So then use the information from the previous slide and fill in the table below. As I said, the first one is done for you. The same thing I've already explained to you. So either you can do it here or you can do that in the table as well here. So go back. So the second one is ZR, the ZR here. So how many protons? What is the atomic number of ZR? Atomic number is the bottom number, that is 40. So you write 40 there, and then neutrons would be 91 take away 40. You write the answer here. Okay, just fill out that table, please. Okay, so then watch the YouTube video and write 5 sentences to show your understanding, what you understand from the video, the important points from that video. And then defining isotopes. So what are isotopes? So isotopes are the atoms of the same element with a different number of neutrons. So we have done in the previous slide that, okay, so there are specific number of protons and neutrons in an element, okay? But the isotopes will have the atoms of the same element with a different atomic number of neutrons. So they will have different neutrons. The protons and electrons are the same, but only the neutrons are different. So for example, hydrogen. Hydrogen has 3 isotopes. So hydrogen, the atomic number, so the number of electrons, you can see it's 1. And protons, like the atomic number is same, but you can see the mass number. So you know the mass number is made up of protons and neutrons together. So they are different here. So number of neutrons are different. Okay. So same atomic number, but different mass number, different neutrons. So now you can fill that chart here as well. So mass number, so at the top is a mass number, so 2. Atomic number is 1. Number of protons, whatever the atomic number is, that is 1. Number of electron is equal to proton, that is 1. The number of neutrons, 2 take away 1 is 1. So you will see in this one, there are 2 neutrons. In here, there are no neutrons. Okay, so you can answer the question after that. Then different kinds of carbon atoms. So like hydrogen, there are different isotopes of carbon as well. So in nature, normally we'll see carbon 12, which has got symbol C, and then mass number 12 and atomic number 6. So can you calculate how many neutrons will this have? You know, for the neutrons, you just take away 6 from 12. So 12 take away 6 is 6. So it has got 6 neutrons. And the other isotope of carbon found is carbon 13 and carbon 14. So it means the mass number here is 13 instead of 12. So find the number of neutrons in here. 13 take away 6 and write it down. In here the same thing, 14 take away 6, write it down. So here are the 3 isotopes of carbon which we were discussing before. Carbon 12, carbon 13, carbon 14. So carbon 12 has got 6 electrons, carbon 13 has got 7, carbon 14 has got 8, and that one is radioactive. Other isotopes examples, so you remember a few of them, maybe for hydrogen, carbon, chlorine, nitrogen, just remember a few of them. Okay, now can you do this? Look at the nuclear symbols for the 4 atoms Z, X, like J, X, Z, and A. These are not the symbols, they are just the letters representing some of the symbols. So you need to find how many of these atoms have 8 neutrons. So how do you find neutrons? The top number take away the bottom number. So just find for all of them and write how many of these have 8 neutrons, and then which of these are isotopes. If they have the same different number of neutrons, then they are the isotope, but with the same number of protons. Okay. So for the modified, students complete all the set activities in the slides and then do the reflection. So as you can see, all these questions, you fill up these ones. Please do them here and submit it. And then other students, there is another slides I have attached for you. So you just need to do one of the activity mentioned there. Okay. So, and submit your work. Hope that makes sense. And I will be available on Google Meet. And if you want, I can also set up a one-on-one session on Google Meet as well. So during the session, please type a comment that you want to come on a one-on-one session, or email me. I can arrange that one. So if you have any questions, so please come on Google Meet or email me, and please share your work as well. Even if you have done one question, two questions for a session, please share it with me so that I know that you are trying and you are getting there. So let me know if you need any help. All right. Have a good day. Bye.